Warning: this video contains clips and excerpts of a humorous nature not normally found in math class. These are intended to fight the adolescent condition known as short attention span, found heavily in the modern teen, especially when in school. The only thing you should attempt at home is the math. The rest, you just laugh at.
Welcome back to AT Math 7-2, powers of 10 in scientific notation. Why it's easier than exercising in most gyms. Alright, well, I know you know scientific notation, but let's do a quick review just to make sure. Scientific notation is a system to measure extreme numbers. What are extreme numbers? Well, imagine crowds of people, or the extremely large, the universe, our national debt. Now, we can also use scientific notation to measure the extremely small, such as bacteria, such as the atom, such as the flea, such as the chance of paying off our national debt. But I digress. Next page. The easiest way to do a scientific notation is to start with a 1, but put the decimal here. So 1.0. Now why do I do that? Because if you have 10 to the first, basically you have 1.0, you're going to move the decimal one space to the right to make 10. So 1.0, one space over, that's 10. Here's another example. 10 to the third power. So go ahead and go 3 spaces over. Becomes 1,000. One more, 10 to the fifth. 5 spaces over, 100,000. Now the one exception to this rule is 10 to the 0 power, but not even really an exception, because 10 to the 0 really is moving nowhere, so still at 1.0, and anything to the 0 power is 1 anyway, so it actually works. But don't forget that anything to the 0 power, let's say 91st to the 0 power, equals 1. 72 to the 0 power equals 1. 1,543,000 and a third to the 0 power equals 1. The long story as to why, simply put, it strips of whatever value it was and just gives it a generic one in this place. Now the reverse is true as well. For negatives, 10 to the negative first power, instead of going 1 to the right, you just go 1 to the left, so it'd be 0.1. And also you can think of it like negative means 1 over, and put the 10 at the bottom, 10 to the first, or just 10. 1/10 is 0.1, so it works out. This, by the way, is perfectly fine, or this as well. Now let's look at a few more. 10 to the negative third. 1, 2, 3. So 3 spaces over, what do you do in the 2 blanks? Put a 0 in there. So 0.001. 10 to the negative fifth, go 5 over. There you have it. Now the next part looks like this. 1.24 times 10 to the third power. Basically, I'm just going to put 1.24. You put the whole thing that's there, then 3 spaces over. 1, 2, 3. Open space, put a 0, 1,240. And the reverse. 1.24 times 10 to the negative third. I have 1.24, but 3 this way. What do I fill with the 2 gaps? Zeros. So 0.00124. Quick break.
Hey, babe. Oh, you jerk. Here, my eyelids are sticking together.
And back. We also can do the reverse, so we can roll it up from into a scientific notation. So take 123,045,000. Well, what you do is you put the decimal between the first 2 numbers. The first number can't be a 0. So if it was like 0, 0, 1, 2, 3, you still put the dot right here, because between the first number that's not a 0 and whatever's after it. So what you do is you put the 1.2 and just count off how many spaces till the end. So 1, 2, 3, 4, 5, 6, 7, 8. 8 spaces. So 1.23045 times 10 to the 8th power. The reverse is true as well. Oh, it's a positive number because it was a real big number to begin with. It was more than 1. Where here, this is less than 1. So the only thing you're going to do is you're going to move it between the first 2 numbers, 3 and 2. And we're going to count 1, 2, 3, Because it was less than 1, it's a negative exponent. So 1, 2, 3, 3.23.065 times 10 to the negative third. Now, you already know all this. Besides, what's this stuff for anyway? Good question. Here's an example. As I'm sure we've talked about a lot of times in class, Earth is 93 million miles away from the Sun. So 93,000,000. If you notice, there's 7 bubbles between 9.3 and the end. So 9.3 times 10 to the 7. As you can understand, anything between 10 million and 99 million fills up the 10 to the 7th power. Now, why is that important, by the way? Actually, our survivability on Earth is within 10 million miles from where we are. In other words, if we were closer than 83 million miles to the Sun, we'd be too hot. No one would live. And if we were more than 10 million miles away still, too cold. Probably no life would be on Earth. Now, take the dwarf planet Pluto. Now, why do I call it dwarf planet? Because on April 24th, 2006, Pluto got demoted. That's right, the same planet that I've been singing that song about and knowing and counting with the planets for 30 years. All of a sudden, they take it away from me and they make it into a dwarf planet just because its moon Eris is larger than the planet itself. Whatever. So now we have 8 planets instead of 9. Anyway, the dwarf planet Pluto happens to be 3.67 billion miles from the Sun. Now, if I write that out, 3,670,000,000, if I count it out and put it in scientific notation, notice that's 3.67 times 10 to the 9th. Now, remember, ours was 10 to the 7th, and theirs is 10 to the 9th. So we're talking about something that's nearly 100 times as far away. Not actually 100, more like 30 or 40, but you get the idea. It's obviously a much larger distance from our Sun. Now, for our final example, our closest star to our Sun is Alpha Centauri. Now, Alpha Centauri happens to be just a mere 25,260,733,353,600 miles away. You know, right around the corner. Wow, 25 trillion, that's such a big number. Almost like our debt will be probably in like 3 or 4 years. So you'll see. But anyway, 25 trillion in scientific notation, 2.52607333536 times 10 to the 13. Why 13? 13 bumps. Now, by the way, comparing Earth and Alpha Centauri, Earth is 9.3 times 10 to the 7. Alpha Centauri is 2.5 times 10 to the 13th. So, notice that 7 and 13, there's 6 zeros difference, which simply means that 10 to the 6th power is 6 zeros is a million. So basically, Alpha Centauri is about 1,000,000 times farther away than our Sun. We might need a bigger rocket. That's it. We're done. Thanks again. Hey, how about a little wow adventure? Let me show you what I do when I'm not teaching you. Bye. All right, it's dungeon time. First, let's go ahead and kill the sound so I can hear myself think. Nope. Alright, it is now dungeon time. And like any World of Warcraft, if you're a tank, you get right in. There is no wait at all. Go ahead and run around in a circle for a minute while I'm waiting for people to sign up. Actually, I'll check my mail. Nothing good in there. Alright, I guess I could sell all my old stuff. Come on, people. Sign up for the dungeon. Oh! This place again. Now, if you're not aware, this is the World of Warcraft Mists of Pandaria. Why, if you're like me with your level 88, you too could be running this dungeon. Only for the super elite. Let's see here. Switch to combat mode. Healer has to switch specs. Normal, I suppose. Telling him, let me know. Because as the tank, I'm the boss of the group. I control the tempo. But without a healer, I die. The wait. Alright. Waiting on the healer. Come on, healer. Anytime healer. That's dandy. Alright, let's do this. That's right. I attack you. Take that. Ooh.
So I'm just gonna rest for a few minutes.
That's right. Same for your average WoW player. Only the exception. That's right. Oof, I'd kill you. What are you doing? Come on back here. Fight me. That's right. I kill you.
You watching the series?
That's right. What you know. If you can take this on, please.
Okay, good.
That's right. I'll be taking damage. Bring it on, bring it on! Die, die, die. Mm-hmm. Oh, gotta have my sound.